Hi, welcome to the last topic here in Unit 1 for AP Physics C Mechanics. This is topic 1.5, motion in 2 or 3 dimensions. So in an algebra-based course, right, we really just talk about it in 2 dimensions. But here in a calculus-based course, we sometimes may have to bring in the 3rd dimension, right? So this is why we talk about the scalars and vectors way back in topic 1.1. And we touched a little bit about it in the last video when we talked about relative velocities and frames of reference. So let's get started. So motion in 2 or 3 dimensions can be analyzed using the one-dimensional kinematic relationships if the motion is separated into components. That's the big thing when you come into with projectile motion, because the object will move horizontally and vertically, but you can use those kinematics equations to establish those relationships, okay? Velocity and acceleration may be different in each dimension and be non-uniform. So this would be like, okay, so if we had air resistance and you're given the effect of the air resistance on the acceleration due to gravity, okay, which means then the acceleration is not constant anymore, which then makes velocity non-uniform also, okay? Motion in one dimension may be changed without causing a change in the perpendicular dimension. So what does that mean? Their motion is independent of each other, right? So the horizontal motion does not affect the vertical motion, or the vertical motion does not affect the z direction, right? Or the x direction does not affect the z direction, right? So all different combinations of those dimensions. Now, projectile motion is a special case of two-dimensional motion. Remember, it has zero acceleration in the horizontal dimension, and then it has constant non-zero acceleration in the vertical dimension. Now, I know it says one dimension, second dimension, because, right, three-dimensional, right? You may look at something that is effectively maybe traveling in the x and z directions instead of the x and y directions, which you're more accustomed to with algebra-based course. But again, so basically what happens is one of the dimensions will have zero acceleration and the other dimension will have a constant non-zero acceleration, okay? So let's look at an example problem. Now remember, calculus could come into play here, right? And so in fact, in most calculus textbooks, when they teach derivatives, they will actually use position velocity acceleration graphs to show that. And that's kind of similar to what we're going to do here in this example problem. Okay, so here's our example problem. So we have the motion of an object can be described by these two equations. X of t is equal to 4t squared minus 3t. Y of t is equal to 3t cubed minus 2t squared minus 9t. Okay, part A is asking us for the displacement after 2.5 seconds. Okay, part B is asking us for the two equations that would describe the object's velocity in the x, y directions. And C is asking for the velocity. Now, the way you can think about this is anything I plug in for t, that'll give me like my x, my I hat notation. Anything I plug in for t and the y will give me my j hat notation. And so the reason I want to do this is because we're going to use, first of all, it says displacement, so it needs to be a vector. And so that will allow us to get more practice with this vector notation. So what I'm going to do is for each question, or for each equation, I'm going to plug 2.5 in. Okay, so there is my x position, and here is my y position. And again, because calculus plays into this, or because we're talking about non-uniform motion, your x position, right, could be a squared. Your y position could be a cube. It could be a trig function. The good thing is on the AP Physics C formula sheets is that they have has a single page dedicated to calculus, okay, and math of physics C. All right, so when I plug it in, I end up with 17 and a half meters, and I end up with 11.9 meters. So if I want to write this as our displacement, which is our position vector, it's going to be 17.5 I hat plus 11.9 J hat meters. Okay, so what does that mean if I have a coordinate system, right? It's traveled 17.5 meters this way, 11.9 meters this way. So it's at this location, and an arrow that connects those 2 points, or from the initial position of 0 to that dot, that's my position vector. You could also find the magnitude of this by doing, everyone's favorite theorem, Pythagoras, and then using the inverse trig function, inverse tangent function to figure out the angle. But the good thing is just ask us for the displacement, okay? Part B says find the two equations that describe the object's velocity. So remember, velocity is dx dt, right? Or in this case, it could be dr dt, whatever you want to call it. So we're going to take the derivative, right, of dx dt is going to give us v of x. And then we're going to take the derivative of the y function, and it's going to give us v of y. So derivatives, we're going to bring the 2 down, minus 1. This is a 1, bring the 1 down, minus 1. Right? You can see the pattern, minus 2, minus 1, right? Minus 1 here. And then this is a 1, minus 1, bring that 1 down. Okay, so we're going to end up with 8t minus 3 and all that messiness there. Here we're going to end up with 9t squared minus 4t minus 9. Okay, so these are our answers for part B, or the second part because it's bullet pointed. Okay, so these are the two equations that describe the velocity, at any point in time. And now part C is going to figure out what is the velocity function, or what is the velocity vector, right, at 2.5 seconds. So we're going to go v of x of 2.5. So 8 times 2.5 minus 3. And then v of y is going to be 9. Oh, let me keep the same notation going. All right. So we're going to have v of y at 2.5 is going to equal 9 times 2.5 squared minus 4 times 2.5 minus 9. And so we get a I notation of 17 meters per second. And then for the y is going to be 37.25 meters per second. And so the velocity of this object is going to be 17 I hat plus 37.25 J hat meters per second. Okay, so here's our answer to part A. Part B is what's circled there in black. And then part C is what's circled there written in green and circled in green. All right, so as I mentioned, this concludes our Unit 1 for AP Physics C Mechanics. So this is the kinematics unit. In the next unit, we'll, just like in AP Physics 1, sorry, I may have said AP Physics 1 before, but this concludes Unit 1 of AP Physics C, right, the mechanics. And then just like in AP Physics 1, we moved into dynamics, which we'll focus on Newton's laws of motion.